Take two. Okay, so this video is going to be talking about a particular type of chemical reaction called oxidation reduction reaction. Okay, and so oxidation is losing electrons. Reduction is gaining electrons, and so we can use the mnemonic oil rig. Okay, so oxidation is losing electrons, which we'll symbolize by the E with a minus sign. Reduction is gaining electrons. Okay, so there's a lot about this topic that the text doesn't go into, but it also gives you some alternative interpretations for this in terms of organic chemistry. And so oxidation, another way to do this is to add an oxygen atom to the compound, and that will oxidize that compound, or remove hydrogen. Okay, and that will also oxidize the compound. So reduction can be done by gaining electrons or adding hydrogen or remove oxygen. Okay, so notice how these are really opposites of each other, and they actually have to both occur in a chemical reaction. Just like love and marriage, like Frank Sinatra said, you can't have one without the other. Now these reactions in general, just instead of calling them oxidation reduction reactions, and they combine the first parts of these two words, and instead of saying ox-red, it's a whole lot easier to say redox. Okay, so reduction oxidation reactions, redox. Okay, gaining or losing electrons, or gaining or adding oxygen atoms, or gaining or adding or removing hydrogens. Okay, so let's look at some examples and see if we can classify them as oxidation or reduction. Okay, so now in a chemical reaction with tin metal, the element, let's suppose it gets changed to the cation and the +2 cation. Well, in order to do this, you have to remove 2 electrons from tin. Okay, so this is an oxidation because oxidation is losing electrons. This has lost 2 electrons when it goes from tin 0 to tin +2. So this is oxidation. Okay, now this electron has to go somewhere, and that wherever it goes, it's going to do a reduction of whatever it goes to. All right. Let's look at another sort of thing. Let's suppose iron 3 cation is in water, and we add 1 electron to it to become iron with just a +2 charge, also an aqueous solution. Now, iron 3 is iron without 3 electrons, and now it's gained 1, now it's only missing 2, so it has a +2 charge. So this is a reduction. And then finally, the last example we're going to do with gaining and losing electrons will be if we take chlorine gas and add 2 electrons, we'll get 2 chloride ions. And so let's say this is in an aqueous solution like salt water or something like that. And this is also reduction. And the reverse reactions are the opposite process. So for example, if you take 2 chlorides and produce chlorine gas, you'll get 2 electrons coming out. That'll be an oxidation. So if you take 2 electrons, add to tin 2, you get tin metal. That's a reduction. Okay, so let's do some examples with adding or removing oxygen. Okay, so for example, we can take rust. So iron, metal, plus oxygen. Okay, and so it depends on which particular form of oxygen iron we're going to use. Let's do Fe2O3, which is iron 3. We require, for a balanced chemical reaction, 4 iron atoms become 4 iron 3 cations, and then 6 oxides come from 3 oxygen molecules. Okay, so this is, let's see, adding oxygen is an oxidation. Okay. Well, that's kind of literal, isn't it? Oxidation is the adding of oxygen. But the reason it's an oxidation is that the iron is losing electrons in this process. You go from iron 0 to iron plus 3. So adding oxygen will achieve an oxidation of something else because oxygen likes electrons. It will take them from nearly anything. Okay, so of course the reverse process would be removing oxygen. So if the way you actually make steel is you take iron ore that's an iron oxide and remove the oxygen. Okay, and so the last example will be done with hydrogens. And so, for example, if you have a biological enzyme, and I'm just going to use the abbreviation, it's called FAD. It's flavin adenine dinucleotide. Okay, it's a big complicated molecule in biology. But what happens is that you add 2 protons and 2 electrons at the same time. So it's like adding 2 hydrogen atoms, okay? So in your body is H+. That's basically coming from acidic conditions. Electrons will be coming from various chemical reactions in the body. And if you take these and an FAD, you get a molecule with 2 extra hydrogens on there. And so the abbreviation for the reduced form of this is called FADH2 because now we've added 2 hydrogen atoms to this flavin adenine dinucleotide.